So now we're going to take a look at another question from Waves and Thermodynamics. This one is about intensity, and in fact this is a question about a siren. So we are told a siren, which is a point noise source, some kind of speaker of some variety, is outputting noise at an intensity of 7,000 watts per square meter at a distance, at 3 meters distance. So the siren is here at a distance of 3 meters, so very close to the siren, 3 meters. We're told that the intensity is 7,000 watts per square meter. And then we are asked to do two things. A, we're told to calculate the intensity of the siren at 10 meters. And then B, we're asked how far away do you have to be for the intensity to be reduced by 99%. So the first question, how loud is the siren at 10 meters? The second question, a little bit more complicated, it's saying how far away do you have to be in order for the siren to be reduced by 99%. So essentially for the siren to be largely inaudible. So let's have a look at question A. We know that the ratio of intensities, intensity 1 over intensity 2, is equal to the ratio of distances squared. So distance 2 over distance 1 squared. So this is a known rule when working with waves, sound waves and intensities. So we happen to know intensity 1 is 7,000 watts per meter squared and distance 1 is 3 meters. So distance 2 we're told is 10 meters. We need to find intensity 2. Intensity 2 is the unknown here. So we're going to flip all the numbers in this upside down. So we're going to say intensity 2 over 7,000 is equal to distance 2 over distance 1. Well, distance 2 is 10 over distance 1, which is 3, all squared. So this means intensity 2 will be equal to 7,000 times 10 divided by, oh no, we've got these upside down. We've swapped this, we've rearranged this. We have to be very careful here. It's very easy to mess these up. So intensity 2 over 7,000 is d1 over d2. d1 is 3 over d2, which is 10 all squared. Multiply both sides by 7,000. 7,000. This gives us I2 is 7,000 times 3 on 10 squared. Now, this has to be the way we're going to calculate this because the intensity further away has to be less. So we have to be multiplying 7,000 by something less than 1. So it couldn't have been 7,000 times 10 over 3, right? This is a check you can do in an exam, by the way. You can think about the physics of what's going on. You're further away, so it's quieter. You're further away, therefore the intensity is lower. Right? So you can check these as you're going along by logically intuiting how the question works. So 7,000 times 3 on 10 all squared. This gives me 630. So therefore intensity 2 is 630, and that is watts per meter squared. So this is the answer to part A. Now in part B, we are asked how far away do you have to be for the intensity to be reduced by 99%. So initially the intensity was 7,000 watts per square meter. In order for this to be reduced by 99%, intensity 2 has to be 70 watts per square meter. We know that distance 1 was 3 meters, and so now distance 2, this is our unknown. So this is what we're going to try and find in this case. So we'll use our formula, and we'll be very careful when we're plugging these in that we get the order right. I1 over I2 is equal to D2 over d1 all squared. This is the arrangement we want because it's going to put the d2 in the numerator. So we have 7,000 over 70 is equal to 3 over some unknown value, x. We'll just call this d1. That's going to be easy enough. Sorry, d2. Got to get our ordering right here. Very, very easy to mess up this ordering. So d2 in this case is the unknown. We'll leave that as d2 over d1, which is 3, all squared. So this gives us 7,000 over 70 is going to be 700 over 7, which is 100. This is equal to d2 squared over 9. This implies that d2 squared is equal to 9 times 100, which is 900. And so this means that d2 is going to be the square root of 900. So therefore d2 square root of 900, this is going to be 30. And that'll be in meters. So essentially, once you are 30 meters away, the majority of the intensity is gone. 99% of the intensity is gone. And that's what this question has shown us.